Hi everyone, and welcome to an example of model fitting and scoring with BlueSky Statistics. The goal of this video is to not necessarily talk in detail on any of the model fitting algorithms we've selected or the statistics. The goal is to show you how very easily with BlueSky Statistics you can perform very effectively and efficiently the basic model building, data preparation, visualization steps to really improve your efficiency and, more importantly, put the depth and breadth of capabilities that are available in our at your fingertips using an advanced graphical user interface and application interface. So what we're going to do today is build a model to predict customers to make loans to. We've got some bank loan data. The data can be found on the BlueSky Statistics CD. I've given you the path. It's in the sample datasets demo folder. The name of the dataset is customer data for bank loan. The dataset is derived from the UCI machine learning repository, and I've got the link there, and all the data is anonymized. So with that said, let's go into the BlueSky Statistics application. You're looking at the main application window where I have my datasets loaded. I can select any of the datasets and go ahead and analyze these datasets. So I'm going to quickly eyeball the data. When I look at the variables, I like to go into the variables tab. I've just clicked on the variables tab at the bottom. I see age here. I have gender, age, debt, married, whether the person is a bank customer or not. When I look at age and I see the data type as character, that I expect it obviously to be numeric. I'll eyeball the data really quickly. I do see it. There are numbers in that column. I just right click and I say make numeric. And here you see that it's been converted to double numeric. I can do several other rich operations using the GUI very quickly. I quickly eyeball my data and see that the default, whether the customer has defaulted or on a loan or not, is set to true. I can right click and make it factor. The type is logical. Most of the algorithms work much better with factor variable, and here you see the two levels of the factor are true and false. So I went ahead, as you just saw, and clicked make a factor. Let me go ahead and run a summary analysis on this data. I'll do summary statistics for all variables, and I can see the results in the output. The output is divided into two parts. The output window where you see the results of the statistics, that's where my mouse is over and I'm moving up and down. And on the right hand side, you can type in R syntax. We're not really going to be concerned with the R syntax or writing R syntax. Obviously, you can go in and write as much as R code as you want with BlueSky Statistics. Since I'm not going to focus on that today, I'm going to close the window. So I see for my gender column, it is of type character, and there's very little information I see about it because it is a character or string. I definitely want to make it a factor. I see age, and age has a minimum, a first quartile, a median, mean, and so on, as you see, as well as it's got 12 missing values. So I definitely want to treat for the missing values, but I see several of the other variables, married, bank, customer, education level, are all character, and I want to go ahead and make them a string. So I can go to the variables view and I can right click on gender and I can make it a factor, because I get a lot more rich data when I work with factor variables in R. And I really don't want to right click on all the different variables that I have here. My data set is not too large, but in the event that you have data sets that have many variables, you'd want to use this dialog here that's called make factor variable, and you can select all your variables that you want to make factor all in one go, and that makes it easier versus right-clicking in the GUI on several variables. So I can go ahead and make it a factor, and we can examine the results. Gender, I see the two levels of my factor. I see with bank customer, education level, I see the various levels of the factor. And more importantly, I can go ahead and run the summary analysis and see richer data about the variables that I have in my data set. So when I look at summary analysis, I see that there are 468 females, 210 males, and 12 missing values. I have data about age. Again, I see some missing values, debt, married. I see 2 people divorced in my data set, 519 married. A majority of them are married, some singles and some NAs here as well. Bank customers, I have 163 who've never been a customer before, returning customer 2, and I have data, or majority of my data points belong to customers of the bank. And again, I have 6 NAs. And then I have information on education level. So when I look at education level, I see I've got high school, some school, unclassified, technical, grad, dropout. If I want to see the other levels, I can go ahead and do a more detailed factor analysis for education. So I can go under data, or rather analysis, summary analysis, and I can go and choose factor variable analysis. I can choose the factor variable that I'm interested in, and here I have the top factor level sorted by count. I say show the top 30 factor levels, or I can uncheck it and see all the factor levels. In this case, I don't have more than 30 factor levels, so I'll keep it checked. And here I can see the different levels of that education level, and I can see how many data points I have that belong to high school, or how many people have had some school, how many people are grad dropouts, how many people have done a technical graduate degree, and so on. All right, so let's spend a little time talking about missing values. I'll show you how one can approach handling missing values in a numeric variable, as well as how one can approach handling missing values in a factor variable as well. So we talked about age having missing values. Let me go ahead and do a correlation analysis to see if the age variable is correlated with any of the other variables. And what I can do there is, if there is a correlation, I can use the other variable that it's highly correlated with to build a regression model to predict the missing values of age. So let me go ahead and do a correlation test, and let me choose my numeric variables. My goal is to find a variable that's highly correlated with age, and then use that variable to build a regression model that could be used to predict the missing values of age. So I will decide to see a correlation matrix as well as visualize a web plot. So I'm going to ask for some rich visualizations as well, and I'm going to go ahead and click OK. So what we will see in the output pretty soon is not only the standard correlation table that you expect, but also a rich web plot and a correlation plot as well. So here I can eyeball the correlation matrix, and I can see that age is correlated positively with years employed. Let me go ahead to the table and see if it's significant. Yes, I see the p-value is pretty low, and I can conclude there is a relationship. And I can also see the web plot here to understand the correlation between the variables. So now let me go ahead and build a regression model, and let's try and model how age and years employed can be represented by a regression equation. So the name of my model is linear reg model 1. It's good for you to be aware of that, because in your case, you're not going to score this data set. You're more interested in the regression equation, but it's good for you to know the model name that you're created. So I'm going to ask for the plot of the residuals versus fitted, the QQ plot, and so on. And you'll see the results slowly, the results show up in the output right away. So I see the residual versus leverage plot, the QQ plot. I see residuals versus fitted. I can get other model statistics, but in this case, I just want to show you how you can build a regression equation to predict missing values, and the coefficient is years employed is 1.41 and the intercept is 27.04. So now I can simply go into analysis, missing values, and missing values formulae, and I can plug in the formulae that will be used to populate the missing values in age. Okay, so I will use a 1.41 multiplied by years employed plus the intercept, which was 27. Okay, so now with this dialog, only the missing values in age will be populated using this formula below. So we can redo the analysis on missing values and see whether age comes up. So I can go under summary analysis and analysis of missing values, and you will see that the age variable does not show up because there are no more missing values in age. So here you see I have missing values in gender, married, bank customer, education level, ethnicity, and zip code. So obviously we have a lot of other capabilities, and there are many sophisticated ways to do missing value analysis. In the future I'll do a demo on multivariate imputation. You can do simply remove all rows with NAs with this. You can do basic missing analysis, so you would select age and then replace all the missing values in age by mean, median. That's one way you can handle missing values. In our case, we handle missing values using a formulae. So let me talk about missing values in a factor field or a categorical or factor variable. And in this case, I will use associate rules to find the missing values. Now, I'm sure many of you are familiar with association rules, but basically association rules looks at the levels of a factor, the levels of a factor variable in each row to determine what the most likely value for a given factor variable is given the other factor variables in that row. So in my case, I want to look at what factor variables at the end of the day are more likely to be associated with females, what factor variables are going to be more associated with males, and use that to fill the missing values in gender with the appropriate level of the factor. So for instance, if someone has a driver license and they're employed and the education level is unclassified, let's say after the rule or the model, associate rules model looks at my data, tells me that people with these factor levels are most likely going to be female, and if I have a missing value with the female with those same combination of factor levels, I will plug in female in that missing value. That's the goal. So before I jump into factor analysis, I have to prepare my data to do such market basket analysis, or rather the association rules. So I need to get my data ready to be able to run an association rules on it. So the first thing I do is do a data compute. And again, I'm getting my data ready to run the associate rules or the market basket analysis on that variable that I'm creating. So what I want to do here is create a new variable. Let's call it basket. And I want to concatenate all these columns: gender, married, bank customer, education level, and ethnicity. So these are factor variables that I want to concatenate into a single variable, and then I will use associate rules to analyze that single variable and find out those combinations that are most likely going to predict someone being a male or a female. Okay, and in the end, I'm going to use those predictions to populate my missing values. So here there is a slew of different commands. You can just double click on it and you'll get the help. Not only that, the appropriate operation you want to perform will be populated in this field here. Now obviously I don't want to pad or convert my data to upper. What I want to do is concatenate my data. So I'm going to double click on concatenate. I get the help here that you can read. What I need to do is just put in all my columns here that I want to concatenate. This is just sample syntax that's created to make it easier for you. Bank customer, education level. There's a comma after that, and I want all of these different values to be separated by a comma. Okay, so I can examine the syntax if I want, and you can bring up any dialog and hit R syntax to see the R syntax. Just for the sake of it, I'll hit syntax now, and you will see that the syntax has been created in the window here at the bottom, and I can go ahead and execute this syntax as well. Okay, and there you'll see that the appropriate column called basket is created in my data. Okay, so now let's go ahead and run the market basket analysis. The data is in the basket data format. I will go and generate rules. I need to specify the variable I want analyzed. The separator is comma. We created a separator comma as you just saw. I will change the confidence level to 0.7. So on any of the dialogues you bring up, there's a lot of useful help that's available in the dialogue itself that you can read. Not only that, you can click Get Our Help and get additional Our Help as well. And in many of the cases, we also give you links to related material on the algorithms. So you can go ahead and click OK, and you'll soon see the rules in the output. Now, obviously, I'm interested in looking at those rules that tell me that this person is most likely going to be female or male. So I see one here. Anyone who's been to high school is most likely going to be a female. Another one here who is single is more likely to be a female. Someone who's not been a bank customer is most likely to be a female as well. So let me go ahead now, before I apply the rule that I just learned to my data. Let me go ahead and analyze or run a frequencies on gender so you can see how many missing values are in gender. Okay, so we'll see the output really quickly, and what you'll see is there are about 12 missing values in gender. So now let's go ahead and apply the rule that I just created. I'll go into data, I'll go into compute, and I'll do a conditional compute. And in this case, what I'm doing is I'm saying gender. That's the variable I want to modify, and under the condition that gender is NA, okay, is NA gender. And if you read the help here, you'll see is NA is basically testing whether gender has values, or the variable gender has certain rows where there are NA. So if this is true, that's is NA gender is true, and education, and we don't have to type it in, you can just drag and drop the field name so you can make sure you're not making a typo, equals high school. I want to set those NA values to female. Okay, so I can go ahead and run this, or examine the syntax if you want to see the syntax, but I'm going to go ahead and run it in interest of time. And I will redo the frequency analysis, and let's see how many of our NA values uh, were populated. Okay, so I'll click OK. And now, but remember, before I had 12 NAs, now I have 10 NAs. So 2 of my NAs were handled by this. So I can go in now and continue to go through those rules, but in interests of time, I will go ahead and instead of applying the rules by one, I'll go ahead and run a conditional compute that will change all the remaining NAs in gender to female. Again, this is not ideal, but I just want to show you how you can do things in the product and not take time running all those rules that we saw to handle for missing values. So I want to change gender, and if it's NA, I will make it all female. Okay, again, this is not a technique I recommend when you're building models. So that looks good, and if I rerun the frequency analysis, you will see that there are no NAs in gender. Okay, so very similarly, I can treat for all the missing values. As I said, down the road, very soon you will see a video on multiple imputations for missing values as well. So now let me go ahead and make sure I remove all rows that contain NAs. Okay, so again, what I'm doing now is if there's any row in my data that contains an NA, I'm going to remove it. So I'm going to select overwrite the existing data set. I'm going to select all the variables that I want examined for NAs, and if there's an NA, that data is going to be removed. Again, I'm just doing it in interest of time to quickly go to the modeling and some of the visualization capabilities as well. So now I've cleansed my data of any NAs. If I go into analysis of missing values, you should see that I shouldn't see any of the columns that show up with NAs. And there you see the missing values, or NA count, is absolutely empty, and it shows you that all the data, all the variables that I have here have valid values, and you see the count 674, telling you that there are 674 rows of data in each variable that contain missing values. Again, there are no missing values now in the data, and I did that more in interests of time to strip the data set of any NAs. And again, I'm not recommending that you do that. You apply the appropriate techniques to handle missing values, and we'll be putting out more videos on missing values as well. So now let me go ahead and examine the numeric variables in my data set. So I'm going to graphics histogram, and I'm going to select age, det. As you know, you can multi-select as well. You can hold the control key down and select multiple variables. And let me go ahead and run those histograms. Again, I'm trying to get a skew, get a sense of whether my data set is skewed, whether I need to transform it appropriately. So when I look at my numeric variables, I see age is skewed to the right, debt is skewed to the right as well, years employed is skewed to the right, credit score and income are skewed to the right as well. So I can, the data will definitely benefit from a log transformation. I can do that very easily. I can come in and click transform, and I'll select debt, years employed, credit score, income, and I'll select the operation to apply, which is log. I'll enter a prefix for all the transformed variables. So each of those variables above are going to get transformed to a new variable, and I won't overwrite the existing variable. I'll just specify a prefix, log, and the transformed variables will be stored in a log. Again, what I would have done before I did that was also run a box plot to examine which of my numeric variables are better predictors. I can definitely run the box plot on the transform variables as well. I think it makes fine sense to do that. But in this case, just to show you the box plot capability, I can go ahead and run a box plot on any of the numeric variables and specify the factor variable to be default, because I'm trying to study the impact that default has on each of these numeric variables. And you'll see that in the graph really, really quickly to see if the default rate is different. So really quickly, the box plot shows you these are the age of people who have defaulted. Here's the age of people who have not defaulted. Again, the debt ratio of people who've defaulted versus people who haven't defaulted, the years employed, and so on. Okay, so let me go back to my data transformation. You can go ahead and standardize the variables too. All you need to do is select standardized variables, and you can select the variables that you want standardized. So I'm looking for the option here, that standardized variable, and I'm going to go ahead and select age, and here I'm going to give it a prefix of std underscore and the mean will be 0, and the standard deviation would be 1. So here you see all the standardized variable for age. So now my data is in a reasonable state that I can go ahead and build a model. I'm going to build a logistic model, and I'll go under model fitting and choose GLZM. And obviously what I want to predict is the default, whether a person is going to default or not. You need to make that the dependent variable, and my independent variables are going to be my transform variables that I just had. I'm going to select binomial and logit, and go ahead and click OK. So when you see the results here in the output, you can examine the statistics, determine the effectiveness or the predictive power of the model by looking at the statistics. I'm not going to go into that, but what I'm going to do, and what I should have done, is before I built the model, I should have split my data set into train and test, so I can verify the accuracy and other model statistics of the model that I just built. So let me go ahead now. Again, typically before you build your model, you split your data set. So let me go ahead and split my data set. So I'll go under split, and I'll say split for modeling, and I'll do a stratified sample. And what I will do is I will stratify my sample by default, so I can make sure that in the 80% of my training data, so I've got my split percentage, which tells me my data is going to be split into a training and testing data set, and 80% of my data is going to be in the training data set. What the stratified sampling does is it allows you to make sure that customers who are defaulted are proportionately represented in the training and testing data. So I go ahead and do that, and now I will rebuild my model on the training data set. Okay, so you'll see the training data set and the testing data set show up in the data grid really quickly. So here's my training data. And I'll go into history and bring GLZM again. I'll choose default, and I will choose the independent variables. I'll choose binomial, I'll choose logit, and now we will rebuild the model on the test on the training data set. Okay. So now if I really want to determine the accuracy of the model, all I need to do is choose the model that I've just built, and that's GLZM. Again, when you bring up GLZM, the model name is here, and you can give it a model name. You can build multiple models. You can do stepwise on each of the models you've built. There's so much you can do. But I just wanted to show you where we got the model name from. The model name came when you selected the modeling algorithm. We gave you a default model name. As I said, you can change the model name. You can build multiple models. You can, once the model is built, you can run stepwise, and there's a lot you can do here. So now that we built the model, let's score the test data set against the model, and let's see what results we get. So when I click score, I can specify a prefix for the predicted values and the supported statistics. So I'm going to do PR_LR. So that's predictions for logistic regression. And I'm going to generate a confusion matrix, and I'm going to click OK. And let's see what how accurate, or let's examine the model statistics. So here I see the confusion matrix, I see the accuracy and kappa statistics. Accuracy is 0.8 against my test data, and the sensitivity is 0.88. So let me go ahead now and build a regression model. Again, I go back to model fitting, or rather a trees model, a decision trees model instead of a regression model. And what I will predict again is my default. And what I will choose is the variables here as well as the variables here. Okay, so I will go ahead and click OK, and we will see the model statistics in the output. Again, I'll do detailed videos on each of those models. But for now, let's quickly run a couple of models without going into the details of each of those models. Okay. So you'll see the output really quickly. You'll see the tree. You'll see the variables, the variable importance. You'll see the CP table, so on and so forth. Okay, again, the name of the model that we created was tree model 1. That's the name we saw there on the top. That's the model name, and you can change that. Now let me go ahead. Oh my gosh, I built this model on the test data set. So let me go back to the trained data set and rebuild that model. So we'll overwrite the model because we accidentally built it on the test data set instead of the trained data set. So we will select gender, we'll select these variables, we'll select all the numeric variables that I selected, we'll select default, and we'll keep the model name the same, so that model is overwritten. And let's go ahead and rebuild the tree model, and then we'll switch to the test data set and score the model using the test data set. So let's go to the test data set, and let me select the tree model now, and let me go ahead and score. And here I will call it PR. So this is for the predicted values and the supported statistics, and I'll call it DT for decision trees, and I'll generate a confusion matrix. So now very soon you'll see the statistics of the model. The accuracy has improved, the sensitivity has improved. I'm not going to go to the other statistics in detail. And not only that, I can go into my data set and I can see the predictions for the decision trees. I can see the predictions for the logistic regression. And in that way, I can build many different model types. So under model tuning, now I do have the ability to, let me carefully switch back to my training data, but I do have the ability to use techniques like bootstrap resampling, k-fold validation to build optimal models. Let me go ahead and use bootstrap resampling here. I'm just going to set two resampling iterations. Again, I want to do this more because I don't want you to wait for the model to build. But let's call this, let's choose the random forest technique, and there's a host of different techniques you can pick up. Let's pick as independent variables. And pick up those log variables. Variables to predict is default. Let's call this the tuned random forest model. Let me go ahead and click OK. So now it's going to build a tuned random forest model. The random forest model has certain tuning parameters. The beauty of the model tuning capability is you pick your tuning technique and it automatically tunes and gives you a model which is optimized. In this case, our optimized model that we built was tuned RF. Okay, so now I can go ahead and score the testing data with tuned RF, and we can see how well our random forest model performed. So I'll say tuned RF for tuned random forest and generate a confusion matrix. And let's see if the accuracy of and the sensitivity of the model improves. So you see it's pretty reasonable. Accuracy is 0.8, sensitivity is 0.88. So definitely there's a lot more stuff that I could show you and you could do. You can go in and for the models, you can go in and see model statistics. For the linear models, you can do a stepwise. There's a lot more capabilities in the product, but I hope that this will get you started and showcase some of the model tuning capabilities, the model building capabilities, as well as the scoring capabilities, all built into BlueSky Statistics to help you accelerate your work. So again, we thank you very much for your time. Feel free to reach out to us with any questions at support@blueskystatistics.com, and we hope you enjoy using the product.